Dear students, very good morning to all. In this class, we will discuss two special trigonometry limits and some special limits. Okay, now discuss two special trigonometrical limits. Result 9.1 is subdivision A. Limit theta approaches 0 sin theta divided by theta, which is equal to 1. Okay, which is equal to 1. The second one, limit theta approaches 0 1 minus cos theta divided by theta, which is equal to 0. Okay, which is equal to 0. Result, some important result 9.2 to limit x approaches 0 e power x minus 1 divided by x, that is the power has the factor, then the same factor which is divided by same result. Okay, e power x minus 1 divided by x, which is equal to 1. Okay, which is equal to 1. Result 9.3. So 9.3, limit x approaches 0 a power x minus 1 divided by x, that is a power like as the factor which is divided by the same result, which is equal to log a. Okay, log a when a greater than 0. Okay, a greater than 0. The another one result 9.4, limit x approaches 0 log of 1 plus x, log of 1 plus x divided by x, which is equal to 1. Okay, which is equal to 1. The next one, limit result 9.5, inverse function limit x approaches 0 sin inverse x divided by x, which is equal to 1. Okay, which is equal to 1. Similar to trigonometry function. Okay, similar to trigonometry function, this is inverse trigonometrical functions. Result 9.6, limit x approaches 0 tan inverse of x divided by x, which is equal to 1. Okay, which is equal to 1. Next, result 9.7, limit x approaches infinity, that is limits at infinity. Okay, limits at infinity 1 plus 1 divided by x. Okay, 1 plus 1 divided by x whole power x. Okay, whole power x, which is equal to e. The power numerator have 1 means e power 1. Okay, e power 1. Result 9.8, that is limit x approaches 0 1 plus x whole power 1 divided by x, which is equal to here 1 plus x whole power 1 divided by x means e. Okay, this e. Result 9.9, that is limit x approaches infinity, that is limits at infinity 1 plus k divided by x whole power x, which is equal to, similar to result 9.7 comparing 9.7 and 9.9, limit x approaches infinity, limit x approaches infinity. 1 plus 1 divided by x, 1 plus some constant k divided by x whole power x, which is equal to numerator have 1 means then the resultant like as e power 1. Here numerator have k means then the resultant like as e power k. Okay, e power k. Next to prove some limits. Next to prove some special trigonometry limits. Limit x approaches infinity or theta tends to 0. Okay, theta tends to 0. Sin theta divided by theta, which is equal to 1. Okay, which is equal to 1. Proof. We take a unit circle. Okay, unit circle means then the radius is 1. Okay, then the radius is 1. This is one radius, isn't it? Radius is 1. This is another one radius, 1. This is another one radius, 1. This is another one radius. Okay, 1. Here we take any one point, that is P, on the circle. Okay, on the circle. This is any point P. Then the coordinate is x coordinate like as cos theta, then y coordinates like as sin theta. Okay, to connecting the point P from origin. Okay, from origin we make an angle with the x coordinates, that is theta. Okay, here the point P, draw the line perpendicular to x coordinates. Okay, perpendicular to x coordinates. Okay, here we take one triangle. This is theta. This is the altitude. Okay, that is tan theta. This tan theta. Area of the triangle. Okay, area of the triangle. Area of the triangle, which is equal to half into base into height, isn't it? Yes, this is the unit circle, then radius like as 1, base into height. Okay, that is tan theta divided by 1, half into tan theta divided by 1. Okay, that is tan theta divided by 2. We take sector. This is the sector. Okay, this is sector. We take sector. This is theta. Area of the sector. Area of the sector, which is equal to theta divided by 2. Okay, theta divided by 2. We take another one triangle. This is the sector. Okay, this is the sector. This is angle. Area of the triangle based sides, that is area of the triangle based on sides, that is half into AB sin theta, isn't it? This A and B are radius sides, means like as 1 1 into sin theta, that is sin theta divided by 2. Okay, then the relation between area of the triangle, sector and the triangle is here. Area of the triangle, area of the triangle is less than area of the sector. Area of the sector is area of the triangle. Area of the triangle, that is half sin theta divided by 2. Sin theta divided by 2 less than theta divided by 2 less than tan theta divided by 2. Okay, tan theta divided by 2. Multiply and divided by multiply by 2 divided by sin theta. Okay, 2 divided by sin theta in each term. That is sin theta divided by 2 into 2 divided by sin theta less than theta divided by 2 into 2 divided by sin theta less than tan theta, that is sin theta divided by cos theta. Sin theta divided by 2 into cos theta multiple 2 divided by sin theta. Okay, simplified we get 2 are cancelled, sin theta are cancelled, finally we get 1 less than 2 are cancelled, theta divided by sin theta. Okay, theta divided by sin theta less than 2 are cancelled, sin theta are cancelled, finally we get 1 divided by cos theta. Okay, 1 divided by cos theta. We take reciprocal. Okay, we take reciprocal. Take reciprocal. That is, take reciprocal means the inequality less than, like as, greater than. That is 1 greater than sin theta divided by theta greater than cos theta. Okay, greater than cos theta. Apply limit in each term. Apply limit as theta approaches 0 in each term. Okay, each term. Now apply limit as theta tends to 0 in each term. That is limit theta approaches 0. The function is 1. That is constant function greater than limit theta approaches 0 sin theta divided by theta. Sin theta divided by theta greater than limit theta approaches 0 cos theta. Okay, cos theta. Here in the constant term, this is the constant function. Apply to the limit, we get the result and is itself, that is same result, that is constant 1 greater than limit theta approaches 0 sin theta divided by theta. Here apply limit theta as theta tends to 0, replace theta equal to 0 into the function, that is cos 0. The value of cos 0 is 1. Okay, 1 greater than limit theta approaches 0 sin theta divided by theta greater than 1. We conclude that any function here we classify it to 2 cases. One case is 1 greater than limit theta tends to 0 sin theta divided by theta. It means the value of these functions less than 1. Okay, less than 1. Okay, that is below the 1. Here we take the another one cases. Here the limit theta tends to 0 sin theta divided by theta greater than 1 means the value of the function is greater than 1. Same function like as less than 1 greater than 1 means definitely then the resultant which is equal to 1. Okay, that is limit theta tends to 0 sin theta divided by theta which is equal to 1. Hence proved. Okay. Next, to prove result 9.1 subdivision B, limit theta approaches 0, 1 minus cos theta divided by theta equal to 0. Okay, proof. First of all, we know that one formula in trigonometry formula, that is 1 minus cos 2 theta. Okay, 1 minus cos 2 theta means 2 sin square theta. Okay, 2 sin square theta. Here the given function is 1 minus cos 1 theta. 1 minus cos 1 theta means that is 1 minus cos theta which is equal to 2 sin square theta divided by 2. Okay. Okay, that is sine square theta divided by 2. Okay, 2 sine square theta divided by 2. It means 2 times sine square theta divided by 2 means sine theta divided by 2 into sine theta divided by 2. Okay, sine 2 sine theta divided by 2 into sine theta divided by 2. Okay, here now we take the function, that is limit. Consider the given function, limit theta approaches 0, 1 minus cos theta divided by theta, which is equal to, here 1 minus cos theta, which can be written as limit theta approaches 0, 2 into sin theta divided by 2 into sin theta divided by 2. Okay, sin theta divided by 2 divided by theta. Okay, divided by theta. Here the 2 which can be written as, then the denominator like as 1 by 2, isn't it? Yes, that is limit theta approaches 0, sin theta divided by 2, sin theta divided by 2 divided by theta divided by 2. Okay, theta divided by 2. This is one function. Product in another one function, that is limit theta approaches 0, sin theta divided by 2. Okay, here replace theta approaches 0 means replace theta equal to 0 into the function. Here we know that the result 9.1, that is limit theta approaches 0, sin theta divided by theta, which is equal to 1. Similarly to the same procedure, limit theta by 2, then the denominator like as theta by 2, theta by 2, theta by 2. Suppose theta by 4 divided by theta by 4. Okay, then the resultant is 1. Here, then the resultant is 1 into replace theta equal to 0 into the function, that is sin 0 divided by 2. Anything 0 by 2 is 0, sin 0 is 0, 1 into 0, which is equal to 0. Hence proved. Okay. Next to prove result 9.2, limit x approaches 0, e power x minus 1 divided by x, which is equal to 1. Okay. Proof. We know that the value of e power 1, which is equal to 1 plus 1 divided by 1 factorial plus 1 power 2 divided by 2 factorial plus 1 power 3 divided by 3 factorial plus and so on. Okay. That similarly to the same process, e power x, which is equal to 1 plus x power 1 divided by 1 factorial plus x power 2 divided by 2 factorial plus x power 3 divided by 3 factorial plus and so on. Okay. Here e power x minus 1 means, consider, now we take e power x minus 1 means e power x is 1 plus x power 1 divided by 1 factorial plus x power 2 divided by 2 factorial plus x power 3 divided by 3 factorial plus and so on. Finally subtract minus 1. Okay, plus 1 minus 1 are cancelled. Finally we get e power x minus 1, e power x minus 1 divided by x means divided by x in each term, that is x divided by 1 factorial is 1 divided by x plus x square divided by 2 factorial divided by x plus x power 3 divided by 3 factorial divided by x plus and so on. That is e power x minus 1 divided by x, which is equal to, here x are cancelled, that is the first term is 1 plus here x are cancelled. Finally we get x power 1 divided by 2 factorial plus here x are cancelled, that is x square divided by 3 factorial plus x power 3 divided by 4 factorial plus and so on. Okay. Now apply to the limit, apply limit apply limit as x approaches 0, as x approaches 0, that is limit x approaches 0 e power x minus 1 divided by x, which is equal to limit x approaches 0 1 plus x power 1 divided by 2 factorial plus x power 2 divided by 3 factorial plus and so on. Okay, here replace x equal to 0 into the function. 0 divided by 2 factorial is 0, 0 divided by 3 factorial is 0 plus and so on. Here finally we get 1 plus 0 which is equal to 1. Okay, which is equal to 1. Hence proved. Next to prove result 9.3, limit x approaches 0 a power x minus 1 divided by x which is equal to log a for a greater than 0. Okay, proof. We know that exponential function and logarithmic function both are inverse function, isn't it? Yes, we know that exponential function and logarithmic function are inverse function. Okay, are inverse function. Similarly to the same procedure, a power x and log of x to the base a. Okay, log of x to the base a are inverse function. Okay, are inverse function. Okay, that is f of x, which can be written as exponential of log of f of x, isn't it? Exponential of log of f of x. Okay, here a power x is the function. Okay, a power x is the function. Here a power x, which can be written as exponential, that is exponential of log of f of x is a power x. Okay, a power x. Here a power x, which can be written as e power x into log a. Okay, e power x into log of a. Okay, because using power rule, e power x into log a, using power rule, which can be written as e power log of a power x. Here both are inverse function. Finally we get a power x. Okay, a power x, which can be written as e power x into log a, that is a power x. Finally we get a power x. Similarly to the same procedure, a power x, which can be written as e power x into log a. Okay, e power x into log a. Here minus 1 means, okay, minus 1 means minus 1 divided by a power x means, okay, a power x means here e power x into log a. Similarly to the same procedure, a power x minus 1, okay, a power x minus 1 divided by x, which is equal to here e power x into log a. Okay, e power x into log a minus 1 divided by x. Okay, divided by x. Listen, we know that the result 9.2, we know that result 9.2, that is limit x approaches 0 e power x minus 1 divided by x, which is equal to 1. E power x means denominator like same result. Okay, e power x means denominator has same result. Similarly to the same procedure, e power x into log e, but denominator have only x. We want to log a, denominator 1 to x into log a. So product and multiple and divided by log a. Okay, that is a power x minus 1 divided by x, which is equal to e power x into log of a minus 1 divided by x into multiple and divided by log a. Doesn't change the value, okay, but change the format. Okay, change the format. Apply limit x approaches 0. Apply limit as x approaches 0, that is limit x approaches 0 a power x minus 1 divided by x, which is equal to here e power x log a minus 1 divided by x into log a. Group of limit x approaches 0 e power x log of a minus 1 divided by x into log a. Okay, x into log a. Okay, into log of a. Here replace x using result 9.3, then the resultant is 1. Okay, then the resultant is 1. Here 1 into log a, here 1 into log of a, which is equal to log a, hence proved. Okay, next to prove limit x approaches 0 log of 1 plus x divided by x, which is equal to 1. Proof: let y equal to log of 1 plus x. Okay, 1 plus x. Here x approaches 0 means, yes, limit x approaches 0 means, then here x approaches 0 means log of 1 plus 0 is log 1. Okay, the value of log 1 which is equal to 0, then the resultant y approaches 0. Okay, y approaches 0. Given function replace x means, okay, replace x means here here take exponential on both sides e power y, which is equal to e power log of 1 plus x. Here e exponential and log are inverse function, then the resultant is 1 into 1 plus x e power y, which is equal to 1 plus x. X equal to, then the resultant e power y 1 goes to left hand side like as negative sign e power y minus 1, which is equal to x. Okay, here the given function limit x approaches 0 log of 1 plus x divided by x, which is equal to limit x change to y approaches 0 log of 1 plus x, which is equal to y. Okay, log of 1 plus x, which is equal to y divided by x is e power y minus 1. Okay, e power y minus 1. We know that the result, that is result 9.2 limit x approaches 0 e power x minus 1 divided by x. E power x means then the factor like as denominator, which is equal to 1. Okay, which is equal to 1. Using this property into here, that is limit y approaches 0 1 divided by y goes to denominator, that is e power y minus 1 divided by y. 1 divided by e power y minus 1 divided by y. Here apply to the limit, then the resultant is equal to 1. Therefore limit x approaches 0, log of 1 plus x divided by x, which is equal to 1. Hence proved. Exercise 9.4. Evaluate. First question, limit x approaches infinity, 1 plus 1 divided by x whole power 7x. Okay, we know that two result, limit x approaches infinity, that is limits at infinity, 1 plus 1 divided by x whole power x. Okay, x approaches infinity, 1 plus 1 divided by x whole power x, which is equal to the numerator like the constant is numerator like as constant means then the resultant is e power 1. Okay, e power 1. In the another one result, limit x approaches infinity, 1 plus some constant k divided by e k divided by x whole power x, which is equal to numerator like as some constant, that is k means then the resultant like as e power k. Okay, e power k. Similarly to the same procedure, given problem solution, given limit x approaches infinity, 1 plus 1 divided by x whole power 7x, which can be written as limit x approaches infinity, 1 plus 1 divided by x whole power x whole power 7x can be written as whole power x whole power 7. Okay, whole power 7. Okay, we know that the result, limit x approaches infinity, 1 plus 1 by x whole power x, which is equal to e. Similarly to the same procedure, using this result, that is e whole power 7, which is equal to e power 7. Okay, which is equal to e power 7. Next, exercise 9.4. Evaluate. Question number 3. Limit x approaches infinity, 1 plus k divided by x whole power m divided by x. Okay, we know that the result is limit x approaches infinity, 1 plus 1 divided by x whole power x, that is x by 1. Okay, which is equal to e power 1. Limit x approaches infinity, 1 plus k divided by x whole power x by 1, which is equal to e power k. But here given limit x approaches infinity, 1 plus k divided by x whole power m by x, which can m divided by x, which can be written as m into 1 divided by x whole power like as 1 by x. But then the resultant is x by 1. Here 1 by x we cannot change into the structure, so apply limit into the given function. Okay, solution, apply limit into the function, limit x approaches infinity, 1 plus k divided by x whole power m divided by x. We cannot change into the format, so apply limit into the function directly, that is 1 plus k divided by x is infinity. Infinity means anything by 0. For example, 1 by 0. Okay, we take 1 by 0 whole power m divided by 1 by 0. Okay, 1 divided by 0. Here 1 plus denominator have fraction means which can be written as reciprocal, product of reciprocal, that is k into 0 divided by 1 whole power m into 0 divided by 1. Okay, which is equal to k into 0. 0 into anything is 0. 1 plus 0 is 1 whole power m into 0. 0 into anything is 0 whole power 0. 1 power 0, which is equal to 1. Okay, which is equal to 1. Next, exercise 9.4. Evaluate. Question number 4. Limit x approaches infinity, 2x square plus 3 divided by 2x square plus 5 whole power 8x square plus 3. Okay, solution given limit x approaches infinity 2x square plus 3 divided by 2x square plus 5 whole power 8x square plus 3. Okay, which can be written as limit x approaches infinity 2x square plus 3 divided by 2x square plus 5 whole power 8x square. Okay, into limit x approaches infinity 2x square plus 3 divided by 2x square plus 5 whole power 3. Okay, whole power 3. Here we know that the property limits at infinity means limit x approaches infinity 1 plus 1 divided by x whole power x, which is equal to e power numerator like as 1 means then the resultant like as e power 1. Suppose limit x approaches infinity 1 plus k, some constant k divided by x whole power x, which is equal to numerator like as some constant means e power k. Okay, e power k, then the resultant like as e power k. In another one property, limits at the infinity of a rational function. Rational function means limit x approaches infinity p of x divided by q of x, which is equal to coefficient of highest degree of x in p of x, in p of x divided by coefficient of highest degree of x in q of x. Okay, in q of x, using this result into here. Okay, into here. Okay, because limits at infinity 2x square plus 3 divided by 2x square plus 5. Degree of p of x is 2. Degree of q of x is 2. Then the relation between degree of p of x, which is equal to degree of q of x. Therefore, then the resultant coefficient of highest degree of p of highest degree of x in p of x, that is 2 divided by 2. 2 divided by 2 is 1. Whole power 3 is 1. Okay, then the resultant is 1. Here, limit x approaches infinity 2x square plus 3 divided by 2x square plus 5 whole power 8x square. Okay, here using this concept, that is coefficient degree of p of x. Okay, this is degree of p of x. Degree of p of x equal to 2 equal to degree of q of x. Degree of q of x, both are equal means coefficient of highest degree, that is 2 divided by 2 whole power 3. Okay, whole power 3, which is equal to limit x approaches infinity 2x square plus 3 divided by 2x square plus 5 whole power 8x square. Here 2 by 2 is 1. 1 power 3 is 1. Okay, 1 power 3 is 1. 1 into this function is 1 into any function is same result. Okay, same result. Here limit at infinity means we can change into the formula. Okay, we can change into the formula. In the first term, like as 1 1, but here 2x square. So take outside 2x square of numerator and denominator. Okay, that is limit x approaches infinity, take outside of 2x square. Okay, 2x square, that is 1 plus 3 divided by 2x square. This is numerator. Then the denominator like as 2x square 1 plus 5 divided by 2x square. Okay, whole power 8x square. Whole power 8x square. Okay, here 2 are cancelled. X square are cancelled. Okay, here limit x approaches infinity. X approaches infinity, 1 plus 3 by 2 x square, which can be written as, then the numerator is 1 plus 3 by 2 divided by x square. Okay, divided by x square divided by 1 plus 5 by 2 divided by x square whole power 8x square. Okay, whole power 8x square. Okay, here like as p of x divided by q of x whole power some function. We can split p by q, that is limit x approaches infinity, 1 plus 3 by 2 divided by x square whole power x square whole power x square whole power 8. Okay, whole power 8 divided by, then the denominator like as limit x approaches infinity, 1 plus 5 by 2 divided by x square whole power x square whole power 8. Okay, whole power 8. We know that the property limit x approaches infinity, 1 plus k divided by x whole power x, denominator like as x means whole power x. Suppose x square means whole power x square, x power 3 means like as whole power x cube. Okay, here similarly to the same procedure, denominator like as x square means whole power x square, both are same means using this result e power some constant. Okay, e power some constant, that is e power 3 by 2 whole power 8. Okay, this is the numerator. Then the denominator is e power 5 by 2 whole power 8. Okay, that is e power 3 by 2 into 8 divided by 1. Okay, 8 divided by 1 divided by e power 5 by 2 into 8 divided by 1. Here 2 8 are cancelled 4 times. 2 8 are cancelled 4 times. 3 4s are 12, 5 4s are 20. That is e power 12 divided by e power 20. Simplify, that is e 1 divided by e power 8. Okay, 1 divided by e power 8. Exercise 9.4, evaluate question number 6. Limit x approaches 0, sin cube x divided by 2 divided by x cube. Okay, we know that the property limit x approaches 0, sin inverse x divided by x, which is equal to 1. This is the inverse trigonometry function. And the another one result, limit theta tends to 0, sin theta divided by theta, sin theta divided by theta, which is equal to 1. Okay, this is the trigonometry function. In our problem, trigonometry function, sin cube x by 2 means sin x cube divided by 2 cube. Okay, it means sin of x cube divided by 2 cube. Then the denominator like as x cube, but 2 cube means product multiple and divided by 2 cube. Solution, given limit x approaches 0, sin cube x divided by 2 divided by x cube. Okay, then the structure is sin theta divided by theta. Suppose limit theta approaches 0, sin 2 theta divided by 2 theta. 2 theta means divided by 2 theta, which is equal to 1. Suppose limit theta approaches 0, sin cube theta divided by theta cube. Okay, sin cube theta divided by theta cube, which is equal to 1. Sin cube theta means theta cube. Sin 2 theta means divided by 2 theta. Of sine of angle same means then the resultant equal to 1. But sin cube x divided by 2 means x cube divided by 2 cube, isn't it? X divided by 2 whole power 3 means x cube divided by 2 cube. 2 cube is 8. X cube divided by 8. So denominator have x cube. Product multiple and divided by 8, which can be written as limit x approaches 0, sin cube x divided by 2 divided by x cube multiple 8 and divided by 8 of denominator. We can form of this structure, that is limit x approaches 0, sin cube x divided by 2 divided by x cube by 8, which can be written as x by 2 whole cube. Okay, x by 2 whole cube. Then the remaining is 8. That is the constant. That is 1 divided by 8. Then the remaining is 1 divided by 8. Here, using this property, then the resultant is 1. Okay, this is the rough work. Okay, this is rough work. Using this property into here, that is limit x approaches 0, sin cube x divided by 2 divided by x by 2 whole cube. Okay, into 1 divided by 8. Okay, then the resultant is 1 into 1 divided by 8, which is equal to 1 divided by 8. Okay, exercise 9.4, evaluate question number 7, limit x approaches 0, sin of alpha x divided by sin of beta x. We know that the function, that is limit x approaches x naught f of x divided by g of x. This is rational expressions. Okay, which can be written as limit x approaches x naught f of x divided by limit x approaches x naught g of x, when g of x not equal to 0 provided. Okay, similarly to the same procedure, which can be written as limit x approaches 0, sin of alpha x divided by sin of beta x. Okay, which can be written as limit x approaches 0, sin of alpha x divided by limit x approaches 0, sin of beta x. Here replace x equal to 0, sin alpha into 0 is 0, sin 0 is 0. Denominator like as 0. 0 by 0 is indeterminate form. Okay. So using this property, that is limit theta approaches 0, sin of 1 theta divided by theta. 1 theta means 1 theta. Okay, which is equal to 1. Suppose 2 theta means 2 theta. Sin square theta means theta square, which is equal to 1. So in numerator, alpha x means multiple and divided by alpha x. Then the denominator beta x means multiple and divided by beta x of denominator. That is limit x approaches 0, sin alpha x multiple alpha x divided by alpha x. This is numerator. Then the denominator is limit x approaches 0, sin of beta x multiple and divided by beta x of denominator. Okay, then the numerator form it to grouping of this one and denominator grouping of this one, then the structure is limit x approaches 0 sine of alpha x divided by alpha x is one function. Okay, into another one function limit x approaches 0 alpha x. Okay, alpha x, then the denominator like as limit x approaches 0 sine of beta x divided by beta x and sorry then the numerator is alpha x and the denominator is beta x. Okay, denominator is beta x. Okay, beta x, limit is the common. Okay, don't split to the limit, limit is common. Okay, limit is common, limit x approaches 0, limit is common. Okay, limit x approaches 0, limit x approaches 0 because x are cancelled, then finally alpha by beta, then the resultant is 1, then the denominator like as 1. Now split to the limit, that is alpha divided by beta. Okay, alpha divided by beta is the constant. Limit x approaches 0 sine of alpha x divided by alpha x, this is the numerator, then the denominator limit x approaches 0 sine of beta x divided by beta x. Okay, then the resultant is 1, denominator like as 1, that is alpha into 1 divided by beta into 1. Finally we get alpha divided by beta. Okay, finally we get alpha divided by beta. Exercise 9.4, question number 9. Limit alpha approaches 0 sine of alpha power n divided by sine of alpha the whole power m. Okay, here sine theta the whole square, which can be written as sine square theta. Okay, sine square theta, which can be written as sine of theta squared is wrong. Okay, similar to the same procedure, sine theta the whole square, which can be written as sine square theta. Similarly to the same procedure, solution, limit given alpha approaches 0 sine of alpha power n divided by sine of alpha the whole power m, which can be written as limit alpha approaches 0 sine power n of alpha divided by sine of m alpha. Okay, sine power m of alpha, and then the format is, structure is limit x approaches 0 theta approaches 0 sine theta divided by theta, which is equal to 1. The numerator like as power n means denominator like as alpha power n. Okay, alpha power n, and denominator is alpha power m. Multiple and divided by alpha power n in numerator, and denominator is alpha power m divided by alpha power m. That is limit alpha approaches 0, numerator is sine power n alpha multiple alpha power n divided by alpha power n. Okay, then the denominator is sine power m alpha into alpha power m divided by alpha power m. Okay, that is the limit alpha approaches 0, grouping of this one and grouping of this one, that is alpha power n divided by alpha power m into sin power n into alpha divided by alpha power n, sin power m alpha divided by alpha power m. Okay, apply to the limit, then the resultant is alpha power n divided by alpha power m, limit alpha approaches 0, sin power n alpha divided by alpha power n divided by limit alpha approaches 0, sin power m alpha divided by alpha power m. Okay, then the resultant of numerator is 1 and denominator is also 1, that is alpha power n divided by alpha power m 1 divided by 1, which can be written as alpha power n minus m. Okay, alpha power n minus m. Apply to the limit into the function. This is the constant function, this is constant function, which is equal to limit alpha approaches 0. Okay, here limit alpha approaches 0, alpha power n minus m. Okay, then the resultant is 1. Here this is the case, then the resultant which is equal to, here suppose if n m are equal, n equal to m means, for example, substitute n equal to 5, m also substitute equal to 5. 5 minus 5 means alpha power 0. Alpha power 0 means then the value is 1. Okay, then the value is 1. Okay, suppose if m greater than n, it means m greater than n means then the resultant is alpha power negative values. Okay, alpha power negative value means 1 divided by alpha. 1 divided by alpha, alpha approaches 0 means infinity. Okay, infinity. F of x approaches infinity. F of x approaches infinity. Suppose if m less than n means, that is n greater than means positive values, alpha approaches 0 means 0. Okay, if m less than n means then the resultant f of x is 0. Okay.